Okay, we're back for part 2 here, and now let's look at a couple examples of curves, of normal distribution curves. In a normal distribution, the mean score for IQ, the average for IQ is 100, and the standard deviation is 15. If you've ever taken an IQ test and you get some score out there, typically, so the mean is 100, standard deviation number is 15. So what we'll do here is, part A is label the number line with the values for IQs within 3 standard deviations of the mean. Remember that the mean is the number, in this case, the average is also the median, it's also the middle. So this is going to be the 100 right here. To the right would be positive standard deviations. To the left would be negative standard deviations. Now, if the standard deviation is 15, then that means that each space represents 15 points. So 100, what we can do is add 15, and this would then be 115. So if your IQ was 115, you would be 1 standard deviation above the mean. To get to the second standard deviation, add 15 again, and that would be 130. And then if you add 15 one more time, this would get you 145. Now, if we go to the left, instead of adding 15, we would subtract 15. So minus 1 standard deviation would be 100 minus 15, which is 85. And then we would subtract 15 to get 70. And then this would be 55 right here. So for part A, it says to label the number line. Okay, there we are, right there. Notice that, again, here's your average. Here's your average right there. 50% of the population would have an IQ below 100. 50% would be above. Part B, shade the sections that are within 1 standard deviation of the mean. Within means between. Within means between. So that means from minus 1 standard deviation to positive 1 standard deviation, shade that area. And if you remember from part 1 of the notes, this represents 68% of your population right here. So all of this, I'm just going to put a B there because that's part B. Within 1 standard deviation of the mean is from minus 1 to positive 1. Part C, what is the interval of values within 1 standard deviation of the mean? So the interval of values means that's between the scores of 85 and 115. Okay, so this would be from 85 to 115. 85 to 115. Okay, now just a couple things, bits and pieces of information. Madonna's IQ is estimated to be around 140. Madonna is a very intelligent woman. Label her position on the number line. So if you were going to put Madonna on this number line, 140 would be way out here. It would be between 2 and 3 standard deviations. That means that a majority of the population, most people, have a lower IQ score than Madonna does. Now part E, Albert Einstein's IQ was estimated to be around 160. So Einstein is considered a genius. Notice that 160 is off the chart. So when people give you the phrase that something is off the chart, they're literally referring to they're so far to the right or to the left of this curve that you can't even really put them on there. To get to 160, we would actually have to go 1 more full standard deviation. And basically, this number doesn't even exist here. That would be 4 standard deviations, and so this would be Mr. Einstein. Very intelligent human being right there. Okay, so if you had your IQ, if you knew your score, you could figure out where you are on this compared to your other values to other people. Now this also we'll come down here to number 3. Height is normally distributed. It's a normal distribution. So if we take adult female heights, here's your curve right here. If you take adult males, you also see the same curve actually. It even looks like the same width of the curve. The only thing that's going to be different is the values where this thing is occurring. For women, the mean is 64 inches. So 64 on this number line would be right here. There's the mean. And the standard deviation is 3 inches. Oh, I apologize for the sirens in the background. The standard deviation is 3 inches. So if I count 3, 1, 2, 3, that would be 1 standard deviation. That would be 67. And then if I count 3 more, the number 70 would be 2 standard deviations. And right here at 73, that would be 3 standard deviations. Going to the left, 64, if I go left, 1, 2, 3, so 61 is minus 1 standard deviation, 1, 2, 3, so 58 would be minus 2, and 55 would be minus 3 standard deviations. Now what's going to happen with males, on average males tend to be taller, their average is 70. So 70 is the mean for the males. For the women it was 64. Okay, so it's different values. Notice the standard deviation though is the same. So the way that the numbers are spread out is actually the same. We're just starting from different points. So I'm just counting 3. To the right, and then I can go left 3 spaces, so this is minus 1 standard deviation, that's 67, and then 64 is minus 2 standard deviations, and 61 is minus 3. So what I want you to do here is place yourself on the correct graph. Let's say, for example, now I'm going to do this for both men and women. Let's say that the height is 5 feet 8 inches. 5 feet 8 inches. Now we know that there are 12 inches in a foot. So 5 feet times 12 is 60 inches. But if you're 5 feet 8, that means you're 60 plus 8. So your height would be 68 inches. Now notice what happens. If you are female, 68 inches actually puts you above the mean, above the average. But for men, 68 inches is going to put you a little bit below average because it's below 70. So in part B it says approximate your z-score and your percentile. Well, for the women, the z-score, so for females, if this is 68, now the mean is here. So if I count 3 for each standard deviation, notice that we're already past 1 standard deviation. Now, a lot of times you won't be able to calculate this by hand, but because this is in thirds, every one of these points represents 1/3. For females, it would be 1 standard deviation plus 1/3, 1 extra inch. So the z-score would be 1 1/3, but as a decimal, 1/3 is 0.33. So for females, the z-score is 1.33. All right, what percentile would you be at? Well, let's go to our sheet here. For z-scores, 1.33. So I'm going to come to 1.3, which is right here. Here's the row. And I want to get 1.33. So the first big decimal here is 1.30, and then 1.31. So I'm just going to go across 1.30, 1.31, 1.32. Here's 1.33, 0.9082. So the percentile would be 0.9032, which is 90%. It's the 90th percentile. So if you are in the 90th percentile, that means you're taller than 90% of everybody else, basically, if we're talking about females here. All right, now let's say that we're 5'8", but we are male. So this time, we already plotted it, 68 inches. Notice it's a little to the left of the mean. So we're a little bit below what the typical average is. We are 2 inches below. So the z-score for males, it's going to be negative. Whoops, I'm going to say z equals. It's going to be negative because we're to the left of the mean. Now we're not quite a full standard deviation to the left. So we're not up to -1 standard deviation. It's 2/3 of the way. So the z-score is -2/3. As a decimal, that's 0.66 repeating. I'm going to round that to 0.67, and it'll be negative. Okay, so if you're a male, if you're 68 inches, 5'8", your z-score is negative 0.67. So to find the percentile, we're going to go to the sheet. We want negative 0.67. Now here's negative 0.6, negative 0.60, 1, 2, 3, 4, 5, 6, here it is, 7 spaces. That's negative 0.67, so it's 0.2514, which would put us in the 25th percentile. All right, again, I want to emphasize that being below average is not necessarily a bad thing. Being above average is not necessarily a bad thing. It just depends on what it is you're measuring. Okay? So we're going to stop this video. That's the end of part 2, and you can move on to part 3.